Good evening everyone. Today I am taking a class on infiltration. Now from this diagram we can see different processes like precipitation, infiltration, surface runoff, and also we can see the water table. So from this very diagram we are able to understand the process of infiltration. Now infiltration has a major role in hydrologic cycle as well as in contributing water to the groundwater sources. So what is this infiltration? Before that, we can understand a simple concept of hydrologic cycle. Hydrologic cycle starts with the precipitation. Once the precipitation occurs in the form of rainfall and snowfall, it reaches the surface of the earth, and some of it first initially get into form of this interception and depression storage. Interception itself means the volume of water that is caught by the vegetation and that which is subsequently getting evaporated is known as the interception loss, while the depression storage is that which is the volume of water that is trapped in the depressions. Now what is this infiltration? Infiltration means the volume of water that is getting seeped into the surface strata of the earth. Therefore, infiltration has a very important role. Now, first thing which we need to study about infiltration is the infiltration capacity. Infiltration capacity can be defined as the maximum rate at which a given soil at a given time can absorb water. Now, from this diagram we are able to understand once the water gets precipitated, it gets into ground layers, the subsurface layers of the earth through the process of infiltration, which finally forms a part of the groundwater. Hence, infiltration is having a very important role in contributing groundwater and much greater source of available water. Now from this diagram we are able to see that more infiltration is happening for porous soils, while less infiltration is happening for non-porous soils. We know clay as well as sandy soil, clay soil and sandy soil. Clay soil being less pervious than sandy soil will be having a lower infiltration rate compared to sandy soil. That means more infiltration will be occurring for sandy soils. And that part of water which does not infiltrate will be going as surface runoff. Clay soils will be having a lesser infiltration rate, or its capacity will be low to absorb water compared to sandy soils. And also the concept of infiltration capacity, or the maximum rate at which the soil can absorb water for any given soil, decreases with time. As the time increases, this infiltration capacity decreases, or the capacity to absorb water decreases. So for this concept we seek the help of Horton's equation. Horton's equation is used to express the decay of infiltration capacity with time. Horton's curve is a very important curve, a graphical representation for this purpose. Now we have the Horton's infiltration graph here. In this infiltration graph, in this infiltration curve, we can see the infiltration rate on the y-axis having unit centimeter per hour, or it can be mm per hour, and on x-axis we are having the time. Time can be in minutes or it can be in hours. Now this graph depicts the rate of infiltration decreasing with time. That means it is decreasing with time, means the rate of infiltration going down with time. Initially the infiltration rate is about 5 centimeter per hour at time t is equal to 0 minutes. But as the time proceeds, it starts to decrease, and at a time t is equal to 14 minutes, it reaches a constant rate, a saturation rate which is termed as the final constant rate or the T final. And this is a very important concept which makes us understand that infiltration rate is never a constant value in the beginning. It will be going on decreasing with time, and finally it reaches a saturation point or it reaches a constant rate. So this curve was put forward by Horton, and from this we can analyze so many important things. Initial infiltration, which is given by F0. Then we are given an equation which states that F is equal to Fc plus F0 minus Fc into e raised to minus kt, where F is depicting the infiltration rate at any time t, and Fc is the final constant rate. Now we can say a representation as k. This k is given as, or it is equal to F0 minus Fc by capital Fc. F0, as I told earlier, it is initial infiltration rate. Fc is the final infiltration rate or infiltration rate at saturation, and capital Fc is the shaded area. So from this we are able to obtain k. Now, using infiltration curve or Horton's infiltration curve, we are able to get an idea about the rate of infiltration, the factors affecting the rate of infiltration, and more importantly, time is having a major role. Hence, Horton's infiltration curve is the most important tool for analyzing infiltration as well as related problems. Hope you understand this video. Do like it and subscribe. Thank you.